Okay, so when I talk about an exponential function, let's see what kind of properties it has. Okay, so exponential function. Okay, so when I graph an exponential function, this would be what it normally looks like. Okay, that's a normal exponential function, so you have to understand that property. What is this y-intercept at usually? If I didn't do anything different, what's this y-intercept? It's at 1. What changes that intercept? In this equation, what changes that? The A or the B? If there's an A, it changes. Okay? This graph is increasing. What is telling me that it's increasing? In this equation, what would be going on? If B is greater than 1. Okay? What do we know about what's happening here? This is doing what kind of thing? It is? It's decreasing right here, and it's never going to actually hit 0. Okay? How do we say the domain and range? So what's the domain? What's the left to right? Well, domain will be negative infinity to infinity, all the way left, all the way right. Range is what's the lowest? 0 with a round bracket, and then up, up, up. Okay? The other exponential function that we talked about would look like this. What's the only difference on why this happened versus this? What made this happen? If B is less than 1, you would decrease. So again, y-intercept so A changes the y-intercept, and B is going to be the rate. It's the rate. So it's going to be, are we increasing or are we decreasing? Okay, what if I told you I bought a car for how much money? $28,000 car. And each year it depreciates by 14%. Can you write me an equation that models this situation? So y equals 28,000, because that's where I start. That's my y-intercept. The base to the x. What is that going to be? 0.86. Okay, everyone sees how I'm getting that? I decreased by 14%. So originally I would start at 100, right? Okay, let's say that the COVID cases started at 200. And they were increasing by 6% daily. Write me an equation. Y equals 200 times the rate. What is the rate in this case now? So it's increasing by 6%. So now this is 1.06. Okay, remember you have to be bigger than 1 if you want to increase something. Okay, think you're always starting with that 100%. So you either go up or down from 100%, right? So this was down from 100, that's up from 100. Okay, then we talked about logarithmics or natural log, okay? The general shape for a log was now that, okay? This time, do you remember what changed here from the exponential? This one had a y-intercept, and then it would have no x-intercepts, right? It has a y and no x-intercepts. It doesn't touch that line. And what's going on with this one? It has a x-intercept, but it won't have a y-intercept. So they flip-flop. And what is this x-intercept should it be at? What's the value? At 1. What's the domain and range of a log graph? If it's a natural log graph. Basic one. So what's the domain? 0 to the right. That's a round bracket because we don't hit the 0 line. And the range, it goes down to up. Okay? What do we notice about the relationship of the domain and range of this to the domain and range of this? They are flip-flopping each other, right? The domain of this is the range of that. Okay, what if I threw a number? What does that do if I throw a number into the front of it? It just makes it increase a little faster. Okay, so if I throw a number in the front like that, that's what happens. And what if I throw a negative number in the front of it? What happened on that one? Do you remember if I threw a negative? It's now decreasing. Okay, so that's increasing or decreasing. That's on that one how you know. Positive or negative. It makes it increase or decrease. Okay? That information is very important to know because that's your foundation for knowing everything. Okay? Okay, so recapping. Ready? Let's kind of try to graph this stuff without a calculator. Okay, so we're not going to graph obviously exact points, but let's say, what do we know about this? So this is an exponential. What do we know and what do we know? It's less than 1. So we're going to be decreasing. We're decreasing because it's less than 1. And what about this 4 part of it? What does that change on the exponential graph? Your y-intercept is 4, and you're going to be decreasing. Okay? Is that sunlight coming through the crack or through the floor part of it? Okay, because then I can't do it. Okay. What do we know about the x-intercept? There's not going to be one. It's never going to ever touch that axis. The y-intercept, well, we did that, is 4. The range, so the lowest we're going to go to is about 0. The lowest height, we get close to the height of 0, and then the highest height this graph is infinite. And the domain is negative infinity to infinity. I don't know if I put any of these in the test, but what if I asked you just end behavior stuff? I'm going to throw that on there. It's going from what quadrant to what quadrant? So this is in quadrant 2, and then it goes into quadrant 1, decreasing as it's doing that. It's going from 2 to 1, decreasing. Okay, next graph. Y equals 5 log x. So what does the basic log shape look like? So you have to know that. And the 5 makes this go up a little bit faster versus normally we'd be pretty, that's kind of normal, flat. You're increasing but very slowly. So this is going to be going up a little bit faster now because of the 5. So that's the effect of the 5. It makes it increase faster than the flat. Okay, x-intercept, that crosses at 1. Y-intercept, where is it hitting this y-axis? It's not. And what's the range? What's the domain? So what are we going to do with these? We're going to switch them, right? So this should go there, and this should go there. They would get switched around. Does that make sense? The domain is now 0 to the right. Okay, end behavior is in quadrant 4 to 1, and this would be an increasing function. We're from a 4 to a 1, increasing. Okay, number 3, exponential. So what and what do we know? That's the y-intercept. You'll have a y-intercept of 3. That's the starting value, right? That's where we'd start from. And then 1.2 is going to do what? We're going to increase. So again, if I don't have a graphing calculator, at least I know the basic properties. Okay, I know it should look something like that. So on your test, you're going to not have a calculator. I might make you match some stuff or multiple choice. So know those general properties. X-intercept, there isn't going to be one. It's never hitting that axis. The y-intercept we said was 3. The range and domain should be the exact same as this one, the first exponential, right? Because it's also an exponential. And then the end behavior, similar to the first pattern, we are in quadrant 2 to quadrant 1, but instead of decreasing, now we're increasing. So we're going from 2 into the 1 as we increase. Okay, the last one. So it's a log shape, but there's a negative sign in front of it. So this is my log shape. But now what did the negative do? Makes it flip. It's decreasing now. Okay, so the x-intercept is 1. That doesn't ever change for us. There's no y-intercept. Range and domain. So range and domain is the same as the other log graph. And what are we doing? We're heading from quadrant 1. And then we go into quadrant 4 as we decrease. Okay, let's talk about these 4. We're going to match them. So this one is an ln, so it's going to be like that. This one is an exponential, but it's a 0.4, so we need something to decrease, exponential decrease. Log shape, it's going to be curving like that. Exponential with a base of 2 is going to have something that's increasing like that. Okay, so again, that's my basic properties. Okay, let's do the exponentials. So which shape looks like that? The first one. Okay, that one did something that we hadn't done on the charts before. The range is going all the way to -1 because there was a subtract 1 after, and that's why that happened. Let's do the other exponential here. So do we have an increasing exponential somewhere? The third graph. Okay, now what do you think? Which log might you put where? They both have the same shape, the curving shape. This one or this one? So here's a hint. This one, the x-intercept is where it should be. This one is not. It is down 1. So does that help you? So this log would be this one. And the reason is because the -1 moved my x-intercept. Also, the 5 makes it increase faster, and the 0.8 makes it flatter. It increases slower. How do I get my arrow over there? All the way around? Okay. 0.8, we're increasing slowly. 5, we're increasing faster. Does that make sense?
Sure, drawing a graph. Is the curve is it important? The right curve?
Like drawing it more precisely?
Like those curves?
Oh,
Yeah, because the last one is just 1, right?
yeah, this is at 1. Yeah.
And
Is that what you mean?
isn't that graph supposed to be like that and the second graph? Like the curve of the line?
This guy?
No, on top of that.
This one. Which one am I looking at?
The fourth one.
The fourth one on this? This one?
No,
No.
This one. The one.
I'm back to the top. This one. Yeah.
The curve of that one should be the same as the second one, the 5 log x.
Not because of the negative.
Because it's only 1.
It would start like this, but when I do the negative, it flipped it. Is that what you mean? Okay, I'll answer your question later because I think I might have to see what's going on. Okay, how do we know a pattern is exponential or not? What does it mean to be exponential? It means that you are having the same rate. As you move along, you're always doing the same rate change. So, what did I multiply by? 80 times what equals 60? That's what I want to know. How do I figure that out? How do I get the question mark alone? Then I would divide. So what is 6 divided by 8? 0.75? Okay, now if that's our thing, we're going to take 60 times 0.75, and then we get 45. Do you want to test it? Does it keep working? Does it keep getting us to the other ones? Yep. Yep. Okay. So finding a common multiplier. Okay. I also might give you a chart when I'm just give you the whole chart, and I might say, is it? Yes or no. Okay, so you have to determine, did every single time you do a same multiply, same multiply, same multiply. Okay, given equation, let's go into our calculator. So this will be like the calculator portion. I could be giving you equations on this, or I will be giving you stat edits on this. So here's what we're going to do. Okay, I have to tell you on this one, when you type it in, if you don't put brackets on that exponent part, it's going to not work. Okay?
No, it's on my face.
Now it's on you. You can move to that spot. Okay. Good? Everyone understands why I need that in brackets? Because otherwise, if you didn't, it would do an exponent of just x, and then it would be dividing the whole equation by 2 kind of after, instead of the whole exponent. Okay, let's talk about our window right now. What's a good thought here on what I could use to help me with my window? What do I know about this right now? 50 is the what? That's the y-intercept. And then we're increasing quite big because that's a 10. So what do you think our y max? That's what I'm thinking with our window. Y max is something I want to focus on. What do you want to do? Should we just start with 500? I'm going to do a 500 and see what happens. Okay, it's going pretty fast up because if you're timesing by 10 every time, 50, then the next would be 500, then 5,000. You're going really fast. Okay, so when we did this, B is the bacteria and D is the time elapsed in days. So what does the 50 tell us? 50 is it is the y-intercept, but what does it tell us? It's always the starting. What are we starting here with? Bacteria or days? Which one would be the y part of it? So the starting bacteria. That's how much bacteria we have at the start. Is the bacteria increasing or decreasing? So we already noticed from our graph it's increasing, but how would you be able to explain to me why you knew that? The base is 10, which is bigger than 1. So I knew it was going to increase. That base was 10. How many days until we get to 800,000? So is this an X or is that a Y? That's a Y, so I'm going to do a Y2 intersect. That's what my work is going to be. So now my window situation is going to have to also change, right? Let's go here to the Y max. If we're trying to get up to 800,000, let's go to 1 million. But you better change your scale. If you're going to 1 million, let's go with a 250,000, quarter million. 250,000. Y2 is 800,000. Okay, there's my 800,000, my window's at 1 million. So eventually we get to 800,000. Remember how to do that one? Second calc intersection, enter, enter, enter. So I got 8.41 days. Anybody get that number to match mine? Okay. Okay, we're going to enter this data in for video games released. The number of games sold in thousands. So this doesn't mean there was 142 games sold. It means there was 142,000 games sold. Okay? Also, let's talk about this because it says that we need to use 1 to represent the 2000 year. So that's actually going to be a 1. Therefore, this x value is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you're going into your stat edit now. So you can type 1 to 11. Okay, y equals, get everything out of there. Activate your plot to plot the points. Zoom 9. Okay, do you see the shape of it? It's curving like that, which means it's a exponential or a log. It'd be this is a log shape. Okay, that's a log shape curve. It actually tells us use a log regression to find this. Okay, so we're gonna go stat, calculate, I think it's way near the bottom here, number 9, LN regression. Linear, not linear, LN, which means natural log. Okay, should I have an equation? Y equals vars stat, copy and paste it. Okay, the curve is really fitting my stuff well, so I'm going to deactivate the plot. Okay, now the question says how many games are going to be sold in 2015? So we're going to go trace. What X value is that going to be then? Because somebody said 16, and that makes sense. So that would be trace 16. Did anybody try it? Are our window good, or we have to adjust our window? So if you had done the trace 16, didn't work because the window wasn't big enough to get a 16. So if I make it something bigger than 16, now it should work. Okay, go to 16 and I get, so I'm going to times this by 1,000. So 178.69 games. Okay, because we had to remember that each of those numbers was actually thousands of.